Hi, and welcome to section 2, where you will take your first steps with Spark to process data and visualize results. In this section, we will show you how to load data in our RDD and in more high-level structures as data frame and dataset. The data frame makes it easy to run SQL queries and generate plots. You will also learn how to manipulate rows and columns, manage file formats, and even stream data in your browser. Now we move on to the first video of this section that deals with the Core RDD API. You will be introduced to the resilient data structure, also named RDD, which is the core of Spark. In this video, we are going to take a look at how to read a file from disk. We will show you how to filter and transform the content along with writing it back to disk. First, launch your Zeppelin notebook as seen in section 1.4 and ensure your Spark context is available. Simply type SC in a paragraph and hit Ctrl-Enter, or click on the arrow in the upper right corner of the paragraph. The paragraph will be executed and the result will be printed just below. In this very simple case, the return is just the type of the SC variable. The SC variable can also tell you which version you are using. You only have to ask for sc.version. We are now ready to create our first RDD. The Spark context has methods to parallelize a collection of objects. We will start with a simple list to show you the basics. The parallelize method has an optional second parameter you can use to indicate the number of partitions you want. The resulting type is a org Apache Spark RDD object, which is a distributed collection, in this case a collection of integer objects. Cool! Now you have a distributed collection of integers that spans to any number of nodes a cluster could have. As a collection can be huge, let's simply take the first element with the take method available on the RDD object. If you think your collection can fit into a single node memory, which is obviously the case here, you can invoke the collect method that returns an array and iterate over that array with the map method. As you can see, we use an anonymous function to print a string with a variable I, which are the integer values of our collection. The RDD has numerous other methods. You can consult the Scaladoc or use the autocomplete feature in your favorite IDEA to get the list. In the next paragraph, we use a map partitions with index that takes a function with a partition index as first parameter and an iterator of values contained in that partition. We have written a function myfunc that simply emits an iterator of string which associates a partition ID with each value. So, if you run this paragraph, you will see in which partition your values are stored. You can start again this exercise, but this time define a RDD with a different number of partitions and ensure the map partition with index returns the expected result. Let's move on to loading some real data from a file. We will use a bank.csv file taken from the UCI dataset repository. Download the file from the archive. So the URL will be archive.scs.uci.edu/ml/datasets/bank+marketing. You can view this file in the notebook thanks to the share interpreter. The first line is the header. The next line contains the data, separated by a semicolon. One challenge of data science is to deal with disparate data formats. We have chosen on purpose a non-canonical file format with colon headers as first line and semicolon rather than colon as separator. In typical science processing, you will rather find TSV format. To load the file in a RDD, simply invoke the text file method. This will create your distributed collection of lines. We will call cache to be sure the file is completely loaded into the memory. You can then call count that returns 4522, the actual number of lines in the bank.csv file. If you want to print the lines, just take the first 10 ones in an array. We often want to get the individual columns. The following code does the job. You will first split each line with a semicolon delimiter, then filter out the first line, the one that contains age. So when you work with large dataset, avoid using headers. Then we emit a bank object built with the columns you need, the first, second, third, and fifth columns. We will just ignore the fourth one. Note that we remove quotes, but our code is quite basic, as we don't handle escaped quotes. The generated RDD is available in the bank RDD variable for further analysis. After your analysis, you will have to store your results in a persistent way. One method for this is a save as text file, which will persist the data frame on disk, with as many as partitions you have. You can have a look at each partition files stored on disk in the folder given to the save method. If you have to change the number of partitions, this is also possible. Invoke the repartition method before saving and check with the shell command to list the number of files. In this video, we have learned how to create a distributed data structure with the RDD Spark object. We have seen how to read and write text files.